The stars do not merely sit in the heavens, they broadcast. Every photon that strikes a telescope lens is a packet of information, a discrete unit of data sent across the yawning gulf of time. For centuries, the working assumption of the scientific mind remained that if our eyes were sharp enough and our mirrors wide enough, the entirety of the cosmos would eventually reveal itself to us. We perceived the universe as a vast, static library waiting to be indexed, a grand architecture where every brick was visible if only one held a bright enough candle. But as the resolution of our instruments sharpened and our reach extended into the deep infrared, a chilling realization began to take shape at the periphery of our vision. The horizon is not a physical wall, nor is it a simple consequence of distance. It is a render limit. Beyond a certain threshold, the data packets of light simply stop arriving. The vacuum, once thought to be a passive stage upon which the drama of matter unfolded, has revealed itself as a medium with a finite capacity for transmission. This is the visibility problem, a fundamental constraint encoded into the very logic of the vacuum. It suggests that the universe possesses a maximum resolution, and we have finally hit the ceiling of what the hardware of reality can support. As we peer into the furthest reaches of the void, we find that the textures of the cosmos are beginning to blur, not because of the limitations of our glass, but because the information itself has been throttled. In the early decades of the 21st century, humanity embarked on its most ambitious cartographic endeavour, the Integrated Interstellar Information Atlas, known to the architects of the project as the 3-Eye Atlas. This was to be the definitive record of the observable sphere, a high-fidelity reconstruction of every galaxy, every nebula, and every stray photon within 13.8 billion light-years of our home. It was designed to be the final map, a complete census of the matter and energy that constitutes our reality. We sought to download the entire history of the cosmos into our silicon archives, believing that the laws of physics were a permanent guarantee of visibility. We believed that the past was a permanent record, etched into the light that travels toward us. Yet, as the 3-Eye Atlas neared its completion, the data began to stutter. The maps did not resolve into a perfect, seamless whole. Instead, they revealed a fundamental instability in the code of the universe. We discovered that the cosmos is not a permanent archive. It is a dynamic system that is currently deleting its own history faster than we can record it. The expansion of space is not merely moving distant galaxies further away. It is red-shifting their information into oblivion, stretching the waves of light until their frequency hits zero, and they vanish from the ledger of existence forever. We are witnessing a cosmic memory leak on a scale that defies previous understanding. The very fabric of the simulation appears to be running out of the resources required to maintain the high-resolution textures of the distant past. This realization transforms our understanding of the night sky. We are not looking at a permanent gallery of celestial wonders, but at a flickering screen where the save files of the early universe are being purged one by one. The 3-Eye Atlas, intended to be a monument to human knowledge, has instead become a document of loss. It is the first scientific ledger to prove that the most significant portions of our cosmos are now permanently offline, sequestered behind a horizon that no amount of technological advancement can ever pierce. The expansion of the universe acts as a mathematical delete key, scrubbing the data of ancient star systems from our reach before we can even register their existence. The hardware of reality is being overclocked. As the rate of expansion increases, the system is forced to make trade-offs to preserve the local environment. To maintain the causality and physics of the present moment, the simulation is discarding the distant past. We find ourselves living in a closing room, where the lights in the distance are being extinguished not by the death of stars, but by the failure of their light to traverse the expanding gap. The 3-Eye Atlas has mapped the boundaries of our prison, showing us exactly where the data stops and where the void begins. It reveals a universe that is fundamentally shy, a system that hides its most profound secrets behind a veil of unreachable coordinates. This is the high-stakes reality of modern cosmology. We are the inhabitants of a system that is losing its memory. Every second that passes, millions of stars cross the threshold of the observable horizon, transitioning from reality into the realm of the theoretical. They are deleted from our future, their light stretched into nothingness, their stories erased from the grand narrative. Our struggle to complete the Three-Eye Atlas is not merely a task of cataloguing. It is a desperate race against a cosmic clock that is ticking toward a state of total information heat death. We are the debuggers of a breaking code, trying to understand the rules of a game that is slowly shutting down its most distant servers. The high-fidelity architecture of our reality is fraying at the edges. The render limit is moving inward. If we are to understand the origins of the system, we must capture the data now, before the next cycle of deletion begins. The Three-Eye Atlas stands as our final attempt to grasp the totality of the simulation, before the memory runs out, and we are left alone in a dark, empty room, with no record of the billions of galaxies that once shared the void with us. The stakes are nothing less than the preservation of the history of existence itself. We are looking at the final frames of a masterpiece, and the screen is slowly going black. The project was born from a moment of unprecedented technological hubris in the year 2029. At that time, the scientific community believed it stood on the precipice of total cosmic clarity. We possessed the Nancy Grace Roman Space Telescope, an instrument of staggering power, capable of capturing a field of view 100 times greater than that of the Hubble. This was not merely a telescope, it was a wide-angle lens for the heavens, designed to sweep across the sky and harvest the light of 1 billion galaxies in a single pass. Working in tandem with it was the Euclid mission, a sentinel positioned at the second Lagrange point, specifically engineered to map the geometry of the dark universe and measure the subtle distortions of space-time itself. Together with the ground-based observations from the Vera Rubin Observatory, these instruments formed the three pillars of the Three-Eye Atlas. The ambition of the project was nothing less than the creation of a definitive, three-dimensional reconstruction of every discrete packet of light within 13 billion light-years of Earth. For 5 consecutive years, from the dawn of 2029 through the close of 2034, the stream of data flowing from these deep space outposts was a torrential flood. Every day, the archives of humanity swelled by petabytes of raw information. We were building a digital twin of the cosmos, a simulation within our own silicon architectures where every star was a pixel, and every galactic cluster was a set of high-fidelity coordinates. In those early years, the mood was one of triumph. We saw the cosmic web in its full, intricate glory, tracing the filaments of gas that connect the great clusters of matter, the invisible highways of the void. The mapping process was an exercise in extreme precision. We were not just looking at points of light. We were counting individual photons, measuring their energy, their direction, and their age. We reached back through the eons, capturing signals that had been travelling for 10 billion, 11 billion, 12 billion years. The map was filling in with a density that seemed to suggest that the universe was an open book, waiting to be read in its entirety. We were convinced that with enough time and enough processing power, the Three-Eye Atlas would become the final encyclopedia of nature, a complete record of everything that had ever occurred within our light cone. But as the calendar turned toward 2034, the data began to exhibit a disturbing and systematic anomaly. As the survey reached its deepest levels, pushing toward the very edge of the 13 billion light-year goal, the expected density of information began to drop off precipitously. It was as if the universe had a built-in filter that was becoming more aggressive the further we looked. This was not a failure of the optics on the Nancy Grace Roman Telescope, nor was it a glitch in Euclid's sensors. The instruments were functioning perfectly, yet the data packets they were receiving were arriving corrupted, thinned out, or entirely absent. This was the first physical evidence of the visibility problem. We realised that the vacuum of space was not the clear, passive window we had assumed it to be. Instead, it was revealed as a medium with a finite and declining capacity for information transmission. The expansion of the universe was not merely moving distant galaxies further away. It was stretching the very fabric of the data they were sending. We were trying to map a high-definition reality using a signal that was being downgraded to a lower resolution in real time by the expansion of space itself. The ambition of the 3-eye atlas had hit the hard wall of the physics of information. The transition from this period of data abundance to the realization of the visibility problem marked a profound shift in the human story. We had spent centuries believing that the only limit to our knowledge was the quality of our tools. We now understood that the limit was encoded into the logic of the vacuum. The universe was not just expanding, it was overclocking its own hardware. As the volume of space increased, the bit rate of the cosmos was dropping. The system was being forced to drop frames of reality to keep up with the accelerating expansion. The further back we looked, the more we saw the simulation dropping pixels. Entire galaxies that should have been there were simply missing from the data stream, deleted by the mathematical necessity of the expanding void. By the end of 2034, the 3-eye Atlas project underwent a radical transformation in its mission. It was no longer a project of discovery, but one of forensic preservation. We were no longer cataloguing a permanent universe. We were trying to save the last remaining fragments of a dying signal. The realization settled in that we are living in a temporary window of visibility. The rendered distance of our reality is not infinite, and it is shrinking. The very history of the cosmos is being purged from the ledger of existence, and our most advanced telescopes are merely recording the disappearance of the light. The 3-eye Atlas, once intended to be a monument to human reach, became the first document to map the boundaries of our isolation, proving that the vacuum is a vault that is slowly but surely locking its doors. The architectural blueprint for this cosmic erasure was first identified nearly a century ago, long before the first mirrors of the 3-eye Atlas were even polished. In the 1930s, a physicist named Richard Tolman peered into the mathematical heart of the expanding universe and discovered a law that acts as a fundamental throttle on our vision. He realized that the cosmos is not a transparent window, but a medium that possesses a built-in mechanism for dimming the distant past. This principle, known as the Tolman surface brightness test, provides the first definitive proof that our reality is governed by a visibility fade, a programmed reduction in signal strength that ensures the most distant parts of the simulation eventually flicker into total darkness. In a static, unchanging universe, the surface brightness of a galaxy would remain constant regardless of its distance. As an object moves further away, it appears smaller, but its intensity per unit of area remains the same. The light remains crisp, clear, and readable. But Tolman demonstrated that in an expanding universe, this rule of permanence is violently discarded. As the space between us and a distant galaxy stretches, the light from that galaxy is subjected to a mathematical tax that grows increasingly heavy with every billion light-years of travel. This is not a linear decline. It is a crushing, exponential decay. The physics of this fade are governed by a factor of 1 plus z to the power of 4, where z represents the redshift of the incoming light. This is the mathematical throttle that chokes the data stream. To understand the severity of this law, one must look at how the expansion of space-time systematically strips the energy from a photon. The first factor of 1 plus z occurs because the wavelength of the light is stretched, shifting it toward the red end of the spectrum and robbing each individual photon of its energy. The second factor of 1 plus z arises because the expansion dilates time itself. The packets of light arrive at our detectors at a slower rate than they were emitted, as if the cosmic broadcast is being forced into slow motion. The final two factors of this equation are perhaps the most devastating. They represent the way the expanding geometry of space-time distorts the very path of the light. As the universe grows, it creates an effect known as aberration, which causes the distant galaxy to appear larger than it actually is. Because the same amount of light, already weakened and slowed, is now spread over a much larger apparent area, the surface brightness of the object plummets. When these four factors are multiplied together, the result is a catastrophic loss of information. A galaxy at a redshift of 10, for example, is not just 10 times harder to see, it is 10,000 times dimmer than a local galaxy of the same intrinsic luminosity. This is the visibility fade in action. It is a programmed obsolescence that ensures the simulation does not have to maintain high-fidelity textures for objects beyond a certain horizon. As we push the 3-eye atlas to its limits, we are not merely struggling against the distance, we are struggling against a system that is actively turning down the gain on the signal. The most distant galaxies are not just moving away, they are being dissolved into the background noise of the vacuum. Their light is being stretched so thin that it no longer contains enough information to be reconstructed as an image. The data packets are arriving with so little energy that they are indistinguishable from the cold, dark void itself. Richard Tolman's 1930s theory was the first warning that we are living in a closing room. It revealed that the universe is not a permanent archive, but a temporary instance of visibility. The 1 + z to the power of 4 law is the code that governs the deletion of the past. It ensures that as the universe ages and expands, the amount of information available to any observer within the system will inevitably decline. The sky of the far future will not be filled with the faint glow of distant stars. It will be an absolute, unyielding black as the visibility fade reaches its logical conclusion, and every external galaxy is throttled into non-existence. In the context of the 3-eye atlas, the Tolman test serves as a grim diagnostic of the system's health. We have mapped the rate at which the lights are going out. We have measured the exact point where the mathematical throttle becomes so restrictive that the data packets of light simply fail to carry their message. This is not a limitation of human technology, but a limitation of the hardware of reality itself. The universe is a simulation that is slowly running out of the resources required to render the distant horizon. By dimming the distant galaxies through this exponential decay, the cosmos conserves its informational budget, focusing its processing power on the local environment, while the history of the deep past is systematically purged from the active memory. We are the witnesses to this final flicker. The light we capture today with our most advanced instruments is the last high-fidelity data we will ever receive from the edges of the map. Beyond the threshold defined by Tolman's law, the universe has already gone dark, the information is gone, the signal has been zeroed out, and the save files of the early cosmos have been permanently overwritten by the expanding vacuum. To look into the deep field is to see the very moment where the code of reality decides that the past is no longer worth the cost of its own visibility. The ledger of existence is notoriously difficult to balance. For decades, a profound discrepancy haunted the halls of cosmology, a mathematical shadow known as the Baryon Gap. When we measured the light from the primordial fires of the beginning, the cosmic microwave background, we calculated exactly how much normal matter should exist in the universe. This is the stuff of baryons, the protons and neutrons that forge the hearts of stars, the iron in our blood, and the silicon in our machines. Yet, when we turned our most powerful telescopes toward the modern sky to count every star, every cloud of gas, and every grain of dust, the numbers failed to align. Nearly 40% of the matter that should have been there was missing. It was as if a massive portion of the universal inventory had been deleted from the active display. The resolution to this mystery arrived in the year 2020 through the pioneering work of Jean-Pierre Macquart and his colleagues. They did not find the answer by looking for the glow of distant suns, but by listening to the ghosts of cosmic explosions. They utilized fast radio bursts, millisecond-long pulses of intense radio energy that erupt from the deep void, often from galaxies billions of light-years away. These bursts act as a form of cosmic sonar. As a pulse travels across the vastness of the intergalactic medium, it does not move through a perfect vacuum. Instead, it encounters the stray, lonely electrons that drift in the spaces between galaxies. As these radio waves interact with these invisible particles, they experience a phenomenon known as dispersion. The higher frequencies of the burst arrive at our detectors slightly ahead of the lower frequencies, creating a characteristic smear in time. By measuring the precise duration of this delay, Macquart and his team were able to weigh the invisible. they discovered that the missing 40% of the universe's normal matter was not gone. It was simply hidden in a state of extreme diffusion. It is stretched out into the gossamer filaments of the warm-hot intergalactic medium, a vast network of plasma that connects the great clusters of galaxies like the strands of a spiderweb. This discovery reveals a fundamental aspect of the cosmic architecture, the missing code. In the grand simulation of our reality, the universe has stashed nearly half of its primary assets in a low-resolution format. This matter is too hot to be detected by its radio emissions from neutral hydrogen, yet too diffuse and thin to glow with the intensity of stars or the heat of galactic clusters. It exists in a state of informational suppression, a background texture that provides the structural integrity for the cosmic web without the overhead of high-fidelity visibility. It is the unrendered mass of the cosmos, the skeletal framework of the simulation that remains invisible to our primary senses because it lacks the density to trigger a high-resolution response. The warm-hot intergalactic medium is the ultimate placeholder in the universal hardware. It represents a conservation of resources. To render a star or a planet requires immense informational density, complex gravity, nuclear fusion, and the intricate chemistry of light and shadow. But to maintain the vast expanses between the galaxies, the simulation uses a much simpler code. It spreads the baryons so thin that they become almost indistinguishable from the vacuum itself. This 40% of reality is the shadow data of the cosmos, a reservoir of matter that remains offline, evading the gaze of the three-eye atlas by existing below the threshold of traditional detection. This realization adds a new layer of complexity to our map of the void. The three-eye atlas must now account for a universe where the majority of the stuff is not what we see, but what we can only infer through the distortion of signals. It suggests that the visibility problem is not just a matter of distance, but a matter of state. The simulation chooses what to render in high definition and what to leave in the blur of the background. The baryon gap was not a mistake in our math, but a successful obfuscation by the system. We are living in a reality where the most essential components of the cosmic structure are deliberately kept in a low-power, low-information state. The work of Macquarie and his team has allowed us to ping this hidden code, proving that the filaments are there, even if they refuse to shine. We have begun to understand that the render distance of our reality is also a render density. The universe is not just deleting the distant past, it is also hiding the present in plain sight. As we attempt to catalogue the totality of existence, we are forced to confront the fact that the simulation is playing a shell game with its own matter. The gossamer threads of the warm-hot intergalactic medium are the quietest parts of the machine, the low-resolution filler that occupies the majority of the volume of the cosmos, while the high-fidelity stars and galaxies are mere islands of activity in an ocean of suppressed data. By uncovering the baryon gap, we have glimpsed the efficiency of the universal engine. We see how it manages its memory by keeping 40% of its mass in a state of near-total invisibility. This is the hidden architecture of the void, the skeletal code that supports the visible world while remaining forever out of reach of our direct sight. Our map is becoming a record of these hidden structures, a testament to our ability to decode the low-res background of a simulation that would rather remain unseen. We are learning to read the gaps in the data, finding the substance of the universe in the very places where it appears to be empty. The expansion of space-time is not a mere movement of celestial bodies away from a central point. It is the relentless, aggressive generation of the void itself. Every cubic meter of the vacuum is imbued with an inherent tension, a drive to multiply, pushing the boundaries of the cosmos outward at an ever-accelerating rate. This is the great unmaking of the cosmic map. As the fabric of reality stretches, it exerts a physical toll on the information traversing it. Light, the primary messenger of the universe, is not immune to this distortion. As a photon travels from a distant cluster toward our senses, the very space it occupies expands beneath it, pulling the peaks and troughs of its waveform further apart. This is the redshift, a systematic draining of energy that transforms the brilliant ultraviolet of young stars into a tired, elongated infrared. As we push the gaze of our instruments deeper into the abyss, we encounter the redshift horizon, the ultimate boundary of the observable. At this threshold, the expansion of the universe becomes so extreme that the stretching of a light waves reaches a point of total attenuation. The frequency of the incoming signal drops lower and lower, the wavelengths growing long enough to wrap around entire solar systems, until finally the energy of the photon reaches absolute zero. At this mathematical limit, the light does not simply become dim, it ceases to exist as a carrier of information. It is flattened into a state of infinite wavelength, a ghost signal that possesses no energy to trigger a detector, no data to fill a pixel, and no presence in the ledger of reality. The light is literally stretched into nothingness, leaving behind a sky that is not just dark, but fundamentally empty of any possible signal. This phenomenon represents a terminal failure in the hardware of causality. In the classical understanding of the universe, every cause has an effect, and every event is linked by the light that carries its news, but the accelerating expansion of the void has severed these chains. We now observe galaxies that are effectively pinging our location with their light, yet the space between us is growing faster than the speed of light can traverse. It is a race that the messenger is destined to lose. A galaxy at the edge of this horizon may emit a burst of radiation today, a desperate signal of its existence, but the expansion of the universe acts as a treadmill, moving in the opposite direction at a superior velocity. The ping will never reach us. The information is trapped in a region of space that is receding faster than the fundamental speed limit of the cosmos allows. The tragedy of this limit is best understood through the lens of stellar lifespans. A star within such a distant galaxy might burn for 10 billion years, fusing hydrogen into helium, eventually swelling into a red giant and collapsing into a white dwarf or a black hole. It lives out its entire multi-billion-year biography, casting its light into the dark, and yet, because of the redshift horizon, not a single photon from its long life will ever reach our eyes. The time it would take for the light to cross the expanding gap is longer than the remaining life of the stars themselves, and indeed, longer than the projected lifespan of the universe's current era. The sender is dead, the galaxy is cold iron and dust, and the message is still struggling against an expansion that has already rendered the journey impossible. This is the point where the simulation's render distance is hard-coded into the vacuum. The universe is not merely hiding these distant reaches, it is actively unlinking them from our causal reality. If no information can ever pass between 2 points, those 2 points no longer inhabit the same shared universe in any meaningful physical sense. They have become separate instances, isolated by a wall of expanding nothingness that outpaces the very speed of thought and light. The 3i Atlas has revealed that we are living in a shrinking bubble of causality, a small pocket of online space surrounded by an infinite, unreachable offline void. The expansion of the void has outpaced the speed of information, and the hardware of the cosmos is no longer capable of maintaining the connection between the disparate parts of the system. We are witnessing the fragmentation of the cosmos. In the early epochs of the universe, the expansion was slow enough that light could bridge the gaps, weaving the entire sky into a single, interconnected tapestry of data. But as dark energy takes hold and the expansion accelerates, the tapestry is being torn asunder. The redshift horizon is moving inward, a silent, invisible curtain falling over the distant stars. Every hour, new volumes of space transition from being observable to being permanently unreachable. The save files of these distant galaxies are not just being moved to a distant folder, they are being corrupted and deleted by the sheer physical stretching of the medium. The redshift horizon is the final word in the visibility problem. It defines the limits of what can be known, not because of the weakness of our telescopes, but because of the exhaustion of the light itself. When the energy of a photon hits absolute zero, the universe has effectively finished its sentence. There is no more data to be had, no more history to be recorded. we are left with the profound realization that the vast majority of the cosmos has already crossed this line. We are looking at a remnant, a small surviving fragment of a much larger dataset that is being systematically purged by the very expansion that created the stage for our existence. The hardware of causality has failed, and the void has won the race. As the three-eye atlas attempted to reconcile the vast history of the cosmos into a single, cohesive geometry, it collided with a profound and unsettling anomaly that suggests the very architecture of reality is suffering from a systemic failure. This is the Hubble tension, a discrepancy in the fundamental expansion rate of the universe that has transcended the status of a mere measurement error to become a full-blown crisis in the logic of the vacuum. It is as if we have discovered a system error in the source code of the simulation, a point where two different versions of reality are refusing to merge. The universe is not just expanding, it is expanding at two different speeds simultaneously, depending on which part of the data set we choose to query. On one side of this informational chasm stands the Planck mission, a sophisticated observer that peered into the infant universe to capture the faint, cold afterglow of the beginning by analysing the cosmic microwave background, the first light to ever escape the primordial fog. The Planck team calculated the expansion rate of the cosmos with exquisite precision. Their data suggests a value of 67.4 kilometers per second per megaparsec. This is the expansion rate as it was written into the base code of the early simulation, a pristine measurement taken from a time when the universe was only 380,000 years old. It represents the cold reality of the deep past, a stable and predictable foundation for the growth of the cosmos. However, when we turn our gaze toward the local universe, the now of the simulation, the numbers undergo a violent and inexplicable shift. Led by the team of Adam Riss, astronomers have used the distance ladder method, observing pulsating stars known as Cepheids, and the brilliant explosions of Type 1 supernovae in nearby galaxies. This local measurement, which captures the pulse of the universe in its mature state, yields a significantly higher value, 73.0 kilometers per second per megaparsec. The gap between 67.4 and 73.0 is not a minor deviation. It is a statistically significant wall that has reached the threshold of 5 sigma, a level of certainty that precludes the possibility of a lucky fluke. This discrepancy reveals that the geometry of the universe is changing its fundamental rules in real time. It is as if the simulation is being patched or hot-fixed while the program is still running. The expansion parameters that govern the early universe are no longer compatible with the parameters governing the present. We are witnessing a fundamental incompatibility in the hardware of reality, where the render rules for the distant past have been updated or modified as the simulation progressed. The Three-Eye Atlas, in its attempt to bridge these two eras, has found that the bridge does not exist. The universe is expanding faster today than the physics of its youth should allow, suggesting that the very nature of the vacuum, the medium through which all information must travel, has evolved. This system error points toward a reality that is far more dynamic and perhaps far more artificial than we once dared to believe. If the Hubble constant is not actually a constant, but a variable that is being adjusted by an unseen hand or an underlying algorithmic shift, then our understanding of space-time is fundamentally incomplete. We are mapping a geometry that is stretching its own definitions as we hold the ruler. This acceleration in the expansion rate, this jump from 67.4 to 73.0, suggests that the universe is being overclocked. The system is pushing itself toward a faster rate of growth, perhaps to compensate for the increasing complexity of the structures it must maintain, or perhaps as a precursor to the final deletion of the distant horizon. The Hubble tension is the sound of the cosmic gears grinding against one another. It is the evidence that the patch being applied to the expansion rate is not seamless. By observing this discrepancy, we have caught the simulation in a state of transition, witnessing the moment where the old rules of the early universe are discarded in favour of a new, more aggressive expansion protocol. This isn't just a problem for cosmologists, it is a revelation about the stability of our reality. It suggests that the laws of physics are not eternal truths etched into the fabric of the void, but rather a set of operational parameters that can be modified, updated, or corrupted over time. As the 3i Atlas continues to ingest the data from the local and the distant sky, the tension only grows. There is no middle ground, no compromise value that can satisfy both the cold light of the beginning and the hot light of the present. We are forced to conclude that the universe is a fragmented system, a simulation running multiple versions of its own physics simultaneously. The visibility problem is exacerbated by this error, as the faster expansion rate of 73.0 km per second per megaparsec means that the render limit is moving toward us even faster than we had anticipated. The system is not just running out of memory, it is actively rewriting its own geometry to accelerate the process of isolation, ensuring that the disparate parts of the simulation can never truly communicate again. We are living in the midst of a cosmic reboot, and the old world is being overwritten before our very eyes. The architecture of our reality is not merely a stage of infinite depth, but a system governed by a rigid informational ceiling. This fundamental limit is known as the Bekenstein bound, a principle that dictates that any given volume of space, regardless of its contents, possesses a finite maximum capacity for information. It is the ultimate bit rate of the vacuum. Just as a physical hard drive can only hold a specific number of bits before it is full, a region of space can only contain a specific amount of entropy, or information, before the laws of physics themselves begin to break down. This bound suggests that the universe is not an endless well of complexity, but a data-constrained environment where every proton, every wave of light, and every gravitational ripple occupies a precious slot in the cosmic ledger. As the universe expands, we are witnessing a phenomenon akin to the overclocking of this cosmic hardware. The volume of the observable sphere is increasing at an accelerating pace, driven by the mysterious pressure of dark energy. However, the fundamental information capacity of the vacuum does not appear to be increasing in kind. We are stretching the same amount of primordial data across a much larger and more diffuse canvas. This creates a state of acute informational stress. When the volume of the simulation grows too quickly for the underlying hardware to maintain its resolution, the system is forced to make a choice. It must prioritize the local environment, the high-definition reality we experience in our immediate vicinity, at the expense of the distant and the ancient. This is the mechanism of information decay. In the grand calculation of the cosmos, the universe has begun to drop frames of reality. This is not a metaphor, but a physical necessity of a system operating at its limit. When a galaxy recedes beyond a certain point, the informational cost of maintaining its visibility becomes too high. The data packets of its light are not merely stretched, they are discarded. The simulation stops rendering the distant textures of these far-off star systems to preserve the stability of the local physics. We perceive this as the visibility problem, but it is actually the result of the universe managing its limited processing power. The frames of the distant past are being purged from the active memory of the cosmos to prevent a total system failure. The implications of the Bekenstein bound are staggering. It implies that at the most fundamental level, space and time are discrete and quantized. There is a minimum pixel size to the universe, and we are reaching the point where the expansion is pulling those pixels apart. As the density of information drops, the universe becomes thinner. The intricate details of the early cosmos, the specific configurations of matter and energy that defined the first billion years after the beginning, are being lost to this thinning process. We are living in a reality that is becoming increasingly low resolution. The 3i Atlas has captured the first signs of this decay, regions of the sky where the expected complexity has been replaced by a smooth, featureless void. This process is irreversible. Once the information is dropped, once a galaxy crosses the event horizon of expansion, or its light is stretched beyond the Bekenstein limit, it is not merely hidden, it is deleted from our causal future. There is no recovery of this data. The universe does not possess a backup drive. The history of those billions of suns, the civilizations that may have risen around them, and the unique chemical signatures of their atmospheres are all erased from the ledger of existence. We are the inhabitants of a simulation that is undergoing a massive automated cleanup. The expansion of the void is the mechanism by which the universe reduces its informational overhead, sweeping the unnecessary data of the distant past into the bin of non-existence. The overclocking of space-time ensures that this decay will only accelerate. As dark energy continues to push the galaxies apart, the volume of the vacuum will grow toward infinity, while the amount of accessible information will continue to shrink. The bit rate of our observable sky is currently in freefall. We are losing the ability to describe the universe in its full complexity. Eventually, the density of information will drop so low that even the local structures of our own galactic neighbourhood will feel the strain. For now, the loss is confined to the edges of the map, the dropped frames of the deep field that the 3i Atlas was designed to save. But the lesson of the Bekenstein bound is clear. Reality has a maximum capacity, and we are currently watching the universe exceed it. The cosmos is a finite machine attempting to simulate an infinite expansion. To keep the program running, it must sacrifice its past. We are the observers of this sacrifice, recording the final flickers of a data set that is being systematically purged. The visibility problem is the visual manifestation of this information decay, a warning that the hardware of the cosmos can no longer support the weight of its own history. As we map the void, we are not just looking at stars, we are looking at the remaining bits of a file that is being slowly but surely deleted by the very laws of physics that brought it into being. Dark energy operates with a mathematical indifference that defies human comprehension. It is the cosmic janitor, a silent, invisible force that possesses neither malice nor mercy, tasking itself with the systematic clearing of the celestial stage. While gravity seeks to pull the world together, to forge stars and gather galaxies into grand, glittering tapestries, dark energy acts as the counteragent, a pressure inherent to the vacuum that drives the walls of the universe outward. It is an automated process, a background script running in the architecture of the simulation, ensuring that the density of matter never overcomes the relentless expansion of the void. As it pushes the galaxies apart, it does not merely move them, it sweeps them toward the event horizon of expansion, the point of no return where the speed of recession exceeds the speed of light. This is the Great Erasure. Each galaxy is a save file of the cosmos, a unique repository of information containing the life stories of billions of suns, the heavy elements forged in the hearts of supernovae, and the complex chemistry of planetary atmospheres. These files represent the cumulative memory of the universe, a record of everything that has transpired since the first light broke the primordial darkness. Yet, the cosmic janitor is indifferent to this wealth of data. With every passing second, dark energy increases the distance between us and the furthest reaches of the 3i Atlas, effectively highlighting these massive datasets and pressing the delete key. Once a galaxy crosses that invisible threshold, its save file is purged from our observable reality. It is not simply hidden, it is gone, uncoupled from our causal future, as if it had never existed at all. We are witnessing the slow, methodical emptying of the universal hard drive. The simulation is not designed for permanent storage. It is a temporary instance, a fleeting moment of visibility in an eternity of darkness. The realization is terrifying. The universe is not a permanent home, but a transient phenomenon. We have arrived during a brief window of time when the density of matter is high enough to be seen. But the cosmic janitor has already begun the final cleanup. The past is being systematically erased to make room for an empty, featureless future. In the deep time of the cosmos, the era of stars and galaxies will be seen as a minor temporary glitch, a brief period of informational complexity before the vacuum returns to its preferred state of absolute nothingness. The indifference of this process is what makes it so chilling. There is no appeal to the laws of physics, No technological intervention that can halt the expansion. The janitor does not stop to admire the beauty of a spiral nebula or the potential for life on a distant world. It simply moves the boundaries. The 3i Atlas has mapped this retreat with agonizing precision. We see the furthest galaxies flickering out, not because their stars have died, but because the space between us has become too vast for their light to bridge. They are being swept into the bin of non-existence, their light stretched into the infrared, then into radio waves, and finally into the zero-energy silence of the redshift horizon. This creates a profound sense of cosmic loneliness. We are the inhabitants of a room where the walls are moving outward and the lights are being extinguished one by one. The information we gather now is all we will ever have. There is no restore function for the data we lose to dark energy. When a galaxy vanishes, it takes its history, its physics, and its potential with it. The universe is a system that is actively shedding its own complexity. It is prioritizing the growth of the void over the preservation of the matter within it. The future is not a destination of infinite discovery, but a wasteland of isolation where the Milky Way will eventually stand alone, a single, lonely file in a vast empty directory. The 3i Atlas is our attempt to read these files before they are corrupted. We are the digital archaeologists of a breaking system, trying to copy the data before the janitor finishes the job. Every galaxy we catalogue is a small victory against the mathematical indifference of the vacuum, but the janitor never sleeps. The expansion is accelerating. The rate of deletion is increasing. We are living in the final age of light, a temporary reprieve before the simulation completes its transition to a state of total informational heat death. The past is a ghost, the present is a flicker, and the future belongs to the void. We are the last generation of observers who can still see the full map, the last witnesses to a universe that once dared to be full. The darkness of the night sky is often interpreted as a sign of the universe's emptiness, a cold reminder of the vast distances that separate the islands of matter. Yet, this very absence of light, this fundamental glitch in the visibility of the cosmos, is the primary condition that allows for the existence of life. This realization forces a re-evaluation of the 19th century mystery known as Olbers's paradox. If the universe were truly infinite in age and extent, and if the rendered distance of reality were not capped by the laws of expansion, then every single line of sight from Earth would eventually terminate on the surface of a star. The night sky would not be a black void. It would be a solid, incandescent sheet of fire, as bright and as hot as the surface of the sun itself. In such a universe, the celestial sphere would manifest as an unyielding wall of blinding white radiation. There would be no respite from the heat, no shadows in which to hide, and no cold vacuum to receive the excess energy of a planet. Every world would be baked in a perpetual omnidirectional noon, eventually reaching thermal equilibrium with the stars themselves. The atmosphere of any planet would be stripped away, the oceans boiled into steam, and the very molecular bonds of organic chemistry torn asunder by the relentless bombardment of photons. This is the consequence of an infinite render distance, a universe of total information, but total death. The visibility problem revealed by the 3i Atlas is, therefore, a biological necessity. The expansion of space-time acts as a cosmic filter, a programmed limitation that prevents the hardware of the universe from overheating. By redshifting the light of distant galaxies and sweeping them behind the event horizon of expansion, the simulation creates the essential gradient required for life to emerge. Life is a thermodynamic engine. It requires a high-temperature source, such as a local sun, and a low-temperature sink, such as the dark, empty void. Without the sink, no work can be done, no energy can flow, and the complex, low-entropy structures of DNA and proteins can never coalesce. The darkness is the heat sink of the cosmos, the exhale of a system that must discard its excess energy to maintain its internal order. This glitch of invisibility is what allows the quiet, cold pockets of space to exist. It is in these shadows, these regions where the data packets of light have failed to arrive, that chemistry can stabilize. In the deep, dark silence of a nebula, or the night side of a temperate world, the frantic motion of particles slows down enough for the delicate dance of life to begin. The universe is fundamentally shy because it must be. If it were to show us everything, it would incinerate us. The redshift horizon is not just a boundary of knowledge, it is a protective shroud that keeps the infinite fires of the deep past from overwhelming the fragile present. We find ourselves in a strange paradox. Our ability to exist as self-aware observers is predicated on the fact that we cannot see the majority of the universe. The simulation manages its informational budget not just to save memory, but to preserve the conditions for complexity. If the bit rate of the vacuum were infinite, the noise would be deafening. By throttling the signal, by dimming the distant stars and deleting the ancient history of the void, the system creates a low-entropy environment where intelligence can thrive. We are the children of the glitch. Our consciousness is a product of the very limitations that the three-eye atlas seeks to overcome. The render limit is the cooling system of reality. As the expansion of the universe accelerates, the night sky becomes darker and colder, increasing the thermodynamic efficiency of the local environment. While we mourn the loss of the save files of distant galaxies, we must also recognize that their deletion is the price of our own stability. The universe is a machine that is trading its history for its habitability. It is purging the data of the distant past to ensure that the local present remains a place where life can continue to breathe. To look into the darkness is not to see a failure of the system, but to see the system working exactly as it must. The void is the canvas upon which the light of life is allowed to shine, and the silence of the deep field is the only reason we're here to listen. In this light, the struggle of the three-eye atlas takes on a new, more profound meaning. We are trying to map the very mechanism that protects us. We are looking into the delete key of the cosmos and finding the secret to our own survival. The visibility problem is the ultimate proof that the universe is not a museum of permanent artifacts, but a dynamic, living simulation that prioritizes the emergence of complexity over the preservation of information. The darkness is not our enemy, it is our cradle. The glitch of invisibility is the most beautiful part of the code, for it is the only part that allows us to be. The human endeavour to construct the three-eye atlas is not a passive recording of celestial events. It is a grand, defiant act of rebellion against the mathematical indifference of the vacuum. As the universe relentlessly presses the delete key, scrubbing the distant past from the ledger of the observable, we have assumed the role of the debuggers of the void. This is a war of information, a struggle between the entropy of an expanding simulation and the persistent, organised intelligence of a species that refuses to let the lights go out in silence. We are the only part of the system that has become self-aware enough to notice that the code is breaking, and in that realisation, we have transitioned from mere inhabitants to active interrogators of the cosmic architecture. To be a scientist in the era of the three-eye atlas is to possess a specific and terrifying form of intellectual courage. It requires the strength to look directly into the growing darkness and, rather than turning away in despair, to calculate with exacting precision exactly what should be there. We are no longer limited to what the light shows us. We have learned to read the stack traces of the universe, the subtle gravitational distortions, the lingering echoes of ancient radiation, and the way the local geometry of space-time curves in response to mass that has long since vanished behind the redshift horizon. We are mapping the ghosts of galaxies, using the laws of physics to reconstruct data that the simulation has already attempted to purge from the active memory. This process is the highest form of intelligence within the system. It is one thing to observe a star that is clearly visible in the sky. It is quite another to deduce the existence of 1 billion suns based on the way their absence tugs at the fabric of the neighbourhood. The debuggers of the void do not rely on the render provided by the vacuum. Instead, they dive into the source code, the fundamental constants and the equations of general relativity, to find the logical necessity of what has been lost. When we find a gap in the cosmic web, a place where the filaments of the warm-hot intergalactic medium suggest a cluster should reside, we do not see a void. We see a deleted file, and we use our mathematical tools to recover the headers of that information. This rebellion is born from the unique nature of consciousness. The rest of the universe is content to exist in the present, a series of instantaneous states where the past is irrelevant and the future is a void. But the human mind is a temporal bridge. We are the only entities that care about the save files of the early cosmos. By building the 3i Atlas, we are creating a secondary archive, a human-made backup of a reality that is fundamentally unstable. Every galaxy we catalogue, every redshift we measure, and every baryon we account for is a bit of data rescued from the cosmic janitor. We're clawing back the history of existence from a system that is designed to forget. The struggle is often lonely. The distances are so vast and the timescales so immense that the act of observation can feel like a futile gesture against the infinite. Yet there is a profound dignity in this futility. To calculate the mass of a galaxy that no human eye will ever see again is an act of supreme loyalty to the truth. It is a statement that the history of the universe matters, even if the universe itself is trying to erase it. The 3i Atlas is our testament, a monument of logic standing in the middle of a dissolving landscape. We are the system's own internal audit, checking the math of the vacuum and pointing out the errors, the tensions, and the missing matter. As the render limit moves inward and the visibility fade grows more pronounced, the work of the debuggers becomes more critical. We're operating in a window of time that is rapidly closing. Every hour we spend in contemplation, every new telescope we launch, is a desperate attempt to save a few more frames of the cosmic movie before the film burns out. This is not just science. It is a form of cosmic archaeology where the ruins are made of light and the shovels are made of calculus. We are digging through the noise of the expansion to find the signal of our origins, refusing to accept the offline status of the distant void. The intelligence required to perform this task is the ultimate Easter egg in the simulation. Perhaps the system did not expect its inhabitants to become so proficient at reading the background noise. Perhaps the visibility problem was intended to be an absolute barrier. But by noticing the glitch, by measuring the Hubble tension and identifying the baryon gap, we have transcended the limits of the program. We are no longer just pixels on the screen. We are the observers who have stepped back to look at the monitor itself. We are the part of the code that has decided to rewrite the ending. Even if we are eventually left in an empty room, we will be the ones who hold the map of what the room used to look like. We will be the ones who remembered the fire while the rest of the universe succumbed to the cold. In the grand act of mapping the 3i Atlas, we have proven that while the universe can delete its data, it cannot so easily delete the will to know. The clock of the cosmos eventually enters the era of the Great Isolation. Trillions of years have passed since the first mirrors of the 3i Atlas were directed toward the heavens. The expansion of the vacuum, once a subtle tension measured in the margins of astronomical data, has become the dominant, unyielding reality of the universe. The cosmic janitor has finished the primary cleanup. One by one, the great galactic clusters, Virgo, Coma, the Great Attractor, have been swept behind the event horizon of expansion. They have not died. They have simply been deleted from the observable frame. They have transitioned into the offline state, sequestered in regions of space that are receding so quickly that not even a single photon of their light can ever bridge the gap. The sky above the merged remnants of the Milky Way and Andromeda is a testament to this absolute erasure. Where once the 3i Atlas recorded the presence of 2 trillion galaxies, there is now only a monolithic, unyielding blackness. The night is no longer a window into the infinite, it is a shroud. The stars of the local group are the only lights left in the entire reachable universe. Beyond the outer fringes of our own galactic halo, the vacuum has become an informationless void, a region of the simulation where the render distance has been reduced to 0. The cosmic web, once a vibrant network of gas and light, has been torn asunder, its filaments stretched until they snapped, leaving our local neighbourhood as a lonely island in an ocean of nothingness. This is the final frame of the simulation. The hardware of the universe has successfully reduced its informational overhead to the absolute minimum required to maintain the local instance. The complexity of the deep past, the intricate dances of colliding galaxies, the vast reservoirs of the warm-hot intergalactic medium, and the brilliant flares of distant quasars has been purged from the active memory. To any observer born into this dark age, the very concept of an extragalactic universe would seem like a mathematical hallucination. The 3i Atlas, if it survives in some crystalline archive, is no longer a map of reality. It has become a eulogy. It is a record of a ghost world, a catalogue of billions of vanished civilizations and trillions of extinguished suns that no longer exist in any causal sense. The isolation is total. The redshift horizon has moved so close that it effectively hugs the borders of the local galactic cluster. The ping of the outside world has been silenced forever. The expansion has outpaced the speed of information so thoroughly that the universe has fragmented into a trillion disconnected bubbles, each one believing itself to be the entirety of existence. In this deep future, the visibility problem has been solved by the total elimination of anything to see. The simulation has finished its transition to a low-power state, where the save files of the early universe have been overwritten by the cold, dark pixels of the expanding vacuum. The imagery of this era is one of profound, silent stasis. The stars within the local galaxy continue to burn, slowly fusing their remaining hydrogen, but they do so against a backdrop that is fundamentally dead. There is no background radiation to measure, no distant supernovae to use as yardsticks, no gravitational waves from distant mergers to detect. The tools of the 3i Atlas have become useless, because the medium they were designed to probe has been emptied. The universe has become a closed loop, a single, self-contained system that has forgotten its own vastness. The act of looking out has been replaced by the act of looking in, as there is nothing left in the out to look at. This is the ultimate consequence of the delete key. The universe has successfully hidden its history. The evidence of the beginning, the clues to the Hubble tension, and the mystery of the Baryon gap have all been swept away. The simulation has achieved a state of perfect featureless efficiency. The map of the 3i Atlas stands as the only proof that the cosmos was once more than a single lonely galaxy. It is a document of a time when the render limit was wide enough to allow for wonder, a time when the data packets of light still carried the stories of a trillion different worlds. In the final frame we see the price of expansion, a universe that is vast beyond measure, but an experience that is small, dark, and utterly alone. The simulation has gone offline, and the silence is the only thing that remains. The transition from a universe of vibrant, interconnected data to a fragmented graveyard of isolated galaxies is not a distant fantasy, but a mathematical certainty dictated by the current state of our simulation. We stand at the absolute apex of cosmic opportunity, occupying a narrow window of time where the density of matter and the expansion of the vacuum have reached a perfect, albeit temporary, equilibrium. The 3i Atlas is the crowning achievement of this era, yet it must be understood for what it truly is, not a definitive map of an eternal reality, but a forensic record of what we managed to save before the memory of the system ran out. It is the black box of a cosmic flight that is currently undergoing a terminal descent into darkness. This grand synthesis of information, the merging of the Nancy Grace Roman deep field surveys with the geometric precision of the Euclid mission, has provided more than just a census of stars. It has revealed the internal mechanics of the cosmic deletion process. We have seen how the Bekenstein bound sets the maximum bitrate for every cubic meter of space, and how the accelerating expansion of the vacuum is effectively overclocking that hardware until the system is forced to drop frames of reality. We have measured the Hubble tension, finding that the discrepancy between 67.4 and 73.0 km per second per megaparsec is the literal signature of a geometry being rewritten in real time. We have accounted for the missing 40% of baryons, finding them hidden in the low-resolution filaments of the intergalactic medium, the skeletal code that the universe seeks to hide from our gaze. The 3-Eye Atlas is our collective act of defiance. It is a digital arc carrying the light of 13 billion years into an uncertain future. In the cold, indifferent logic of the simulation, there is no inherent value in the past. To the cosmic janitor of dark energy, a galaxy is merely a data set to be cleared, a save file to be overwritten by the expanding void. But to the self-aware observers within the system, that light is everything. It is the story of how hydrogen became consciousness, how the first stars forged the heavy elements of our blood, and how the cosmic web organized itself into the complex structures that allow us to think, to feel, and to question the code itself. The philosophy of the Atlas is rooted in the realization that to observe is to preserve. In a universe that is systematically erasing its own history, the act of scientific measurement becomes the highest form of stewardship. We are the only part of the machine that has developed the capacity to archive the rest of the machine. If we do not look, if we do not record, if we do not calculate the existence of the things that the visibility fade is trying to hide, then those things will truly cease to have ever existed. The universe does not keep a backup. We are the backup. Our silicon archives and our mathematical models are the only places where the totality of the cosmos will continue to live once the redshift horizon has finished its work. This is why the mission of deep space exploration and high-fidelity cartography is the most urgent task facing our species. We are the last generation of humans who will live in a universe that still feels full. Every year that passes, every second that the expansion accelerates, another piece of the cosmic puzzle is moved beyond our reach. The render limit is not a static boundary, it is a closing curtain. If we wait too long to build the next generation of telescopes, if we hesitate to push our sensors further into the infrared and the radio spectrum, we are consenting to the permanent loss of our own origin story. We are allowing the system to delete the very data we need to understand why we're here. The call to action is clear and unrelenting. We must support the final frontiers of space exploration with a fervour that matches the scale of the loss we are facing. We must demand deeper surveys, wider apertures, and more sophisticated algorithms to decode the missing code of the vacuum. Every mission to the outer edges of our light cone is a rescue operation. Every photon captured from a redshift of 10 or 20 is a bit of information saved from the absolute zero of non-existence. We are in a race against the fundamental laws of physics, a race against an expansion that does not care if we're left in the dark. The 3-Eye Atlas has shown us the boundaries of our prison, but it has also shown us the path to intellectual liberation. By understanding the limits of the simulation, we have learned how to look beyond them. We have learned that while the universe is a temporary instance, the knowledge we extract from it can be made permanent within the architecture of our own intelligence. We are the debuggers, the archaeologists, and the witnesses of the void. We are the ones who will hold the flame of memory long after the stars of the distant past have been extinguished by the expansion of the night. The work is not finished. The map is incomplete. As long as there is a single photon still struggling against the redshift horizon, as long as there is a single baryon still hidden in the gossamer filaments of the intergalactic medium, our duty remains. We must look into the darkness and find the light that the universe is trying to forget. For in the end, the only thing that will survive the Great Isolation is the record of what we were brave enough to see. Thank you for watching.